Welcome back to Science Tunnel. This week we have been talking about very interesting topic in technology, that is nanotechnology and 3D printing. I am Maxwell.
And I'm Isaac.
So, under nanotechnology and 3D printing, we have tried to look into the bioentrepreneurship part, and we identified 4 key aspects in 3D and nanotechnology. The first one, we have the nanoparticle-based fertilizers and pesticides. We also have nano-engineered 3D printed bioreactors. Also, we have tissue formation and product design. So, we look into nanoparticle-based fertilizers and pesticides. You find out that nanoparticle-based fertilizers they're coming to, let me say, to replace or be as alternative to the organic and inorganic fertilizers. These nanoparticle-based fertilizers, they're using the technology of nanotech in designing fertilizers, which are, you find out that they are precise in nutrient delivery. And also, talking of pesticides, these pesticides are not like the inorganic pesticides that are normally used. They are friendly to the plant and also friendly to humans and environment in general. Also, you come and find out that the nano-based biofertilizers, using the nanoparticles, they are very efficient in absorption. There is maximum absorption of the fertilizers, and these are very key aspect in maximum utility of fertilizer. The second one, we have nano-engineered 3D printed bioreactors, where you find out that 3D tissues and organs are designed in specialized equipments. So, these bioreactors, they have been made in such a way that, or they can be designed in a way that they are coated with nanoparticles. These nanoparticles, upon coating to the 3D printer bioreactors, they enhance the cell growth for the development of the tissue or the organs. And as if that is not enough, they are able, combining the aspect of nanotech and 3D tissue printing, you find out that they enhance the production of protein for personalized medicine. Yes. I think you can mention something on tissue formation and product design.
Yeah, sure. So in terms of 3D printing in the tissue space,
Yes.
we have, for example, this research that we saw. Was it last week? They were in Israel.
Yes.
They are doing they're designing tissue, the intestine, in small intestine, to test the absorption of protein according to the different age. So they design one for the young kids, the kids, then one for a middle-aged person and an old-age person. Then they test the absorption capacity to determine what amount of protein will someone need at old age in order to be able to absorb, let's say, for example, an average of 10 grams. So maybe the older person will need like 30 because the absorption is way much less. Then the kid will just need about maybe 12 because the efficiency of the absorption is very high. So you see, they are using this 3D printing technology to design this tissue in order to be able to collect the data necessary to test on absorption. So I think, as you've said, those the bioreactor. I think they're the one that they are being used to develop these tissues. Yeah. And also another thing, especially in the product space, product design, 3D has found a lot of application in that space. You know, in the recent times, industry production was just majorly done in industries.
Yeah.
But now with the ability of 3D printing, someone is able to purchase a 3D printer, then design what they want to design, maybe a case, different equipment. For example, you see this one, you
Yes.
can easily design it using a 3D printer in your house. You just have to design it in the 3D environment and then feed it to the 3D printer, and then you will be able to design it very easily. So I think it's becoming a big space, especially even in the car industry. There is now manufacture of those parts of vehicle using 3D, rather than you now using very different many equipment. You just use a 3D where the metal is shaped in that specific design. So it's ensuring the quality and efficiency. You know, now anything that is being done, it will be done in very much uniform compared to you using different stages. Because you see, this is just producing the same design, the same accuracy and precision. Yeah, I think that's something to look at.
You know, trying to link on the aspects that I've looked into and what you have just tried to explain on tissue formation and product design, and I really like the way you have explained. I'm trying to think of the potential, and I'm concluding. You see, the nanotechnology and 3D printing, they have a very, very huge potential in various fields. Talking of health, talk of agriculture, and also in product design. I've heard even in car industry, metal, in that designing of metal in a certain way that, let's say, in a curved way, you need a metal in a specific shape. They are able, through the technology, you are able to design it. I'm really seeing a very, very great potential in this.
And also I was thinking, is it possible, for example, nanotech, to be applied in genetic engineering? You see, the one now we use enzymes, restriction enzymes, of which you just hope it will cut at the position you want.
Yes.
But how can we be able to use nanotechnology in order to have very precise cuttings, exactly where you want, and then use that same technology to fix whatever you want to enable now mutation? Looking at genetic engineering, it's now something big. Yeah. So that is also something that can be looked at, and I believe with more research, we can identify possible ways to do that.
So, like, the technologies that you have talked about, they have, I can say, limitless applications.
Like the way you're saying in health.
Yeah.
You see, even for example, you can use the same in personalized medicine, public health application. I think these are very big, diverse application. Because you see, the same can also be applied to food tech.
Sure.
Biotech. These are bigger space of application of this.
I can say the most interesting part of me is on personalized medicine. Using these two technologies, you know, you find out that as the time goes, as there are changes in the environment, we are developing different diseases. So the disease that I have, trying to treat it the same way with the one that you have, it's a problem. So with such technologies where they can design a specific model that can help me aid my disease, it's a very positive thing.
Like you see, this 3D printing can be able to design, to just maybe using ultrasound, maybe study the way that your tissue it's the design of your tissue, and then map it out, and then try different medicine on the same. And then if they see there is an efficient reaction on something specific, then they can design that medicine for your specificity.
Just to add, I think a point on the same.
Yeah.
I think, especially in 3D printing,
Yeah.
there's a way they can also design or develop some organs that they are going to be used to test for diagnostics.
Oh, yeah.
Yeah, so you find out that they are developing a certain structure so that they can use the structure to test on a certain disease, and if that disease can be able to be cured just through observing the response of the formed tissue or organ. Yeah, so let's say for example we want to develop a certain drug or for myocardial infarction,
Yeah.
and we find that it is too risky for us to use a human heart,
Oh.
and it's difficult for us to find it.
Oh, yeah.
We can design something
Mm.
that resembles and have the same features of human heart,
Sure.
and try to run some diagnostics. And also it's very important for, let's say, developing I can say learning,
Learning
experimental.
model. Yeah, sure.
Yeah.
Mm.
Very, very important.
Yeah.
So that's I was just trying to back up the point that I was saying, that the applications might be limitless.
Yeah. Because you can apply, as you've you can apply very many things. Because I think it's only that maybe you are looking at it from a limited perspective, but if you just try to look, because the same 3D is being used in construction of buildings, very efficient, fast, so limitless. Yeah, I think that is what we did for this week. So next week we'll be having another topic. It will be health space. In the health space.
Yeah, in the health space.
Yeah.
And just to say, it will be a very, very interesting one.
Yeah. Hey, I find it's interesting, but you just be there, and you will see what you have for you.
Yeah. So keep waiting. You can drop your comments, your views, your concerns,
even your ideas.
Exactly. And maybe you can also mention one of the 4 highlights that you have mentioned, one that you find it's interesting, one that you can add something, any information or anything that we have not really catched on. You can be free to share with us.
Thank you, buddy.